Cool. Well, one of those days. Anyways, welcome back, everybody. As you may or may not know, I'm Eli, the computer guy. This is part of my Silicon Dojo project. Basically, I do tech education on top of all the screaming into a camera on YouTube. And one of the big things that I found is most people do not understand what real technology professionals actually do. And so that's why I bring on real technology professionals to try to explain their worldview and why they're deciding to do what they do, especially in this modern world of AI. And this is really relevant today. Is people do not stop talking about AI. They won't shut up about it. But at the same time, they're not putting money on the table. And so who cares? If they're not putting money on the table, it doesn't matter what they have to say. And so one of the reasons I'm bringing in these AI folks is so we can find out where are they putting 100 grand? Where are they putting their bet? Not that it's right, not that they'll win, but at least that gives you a better idea of what's going on in the world. So I have David Cox here. He is the Vice President of AI Models at IBM. Thank you for showing up today.
Yeah, my pleasure. Thanks for inviting me.
Yeah. So I guess the first place to start. So you're VP of AI Models at IBM, and when you get in the corporate world, titles can be very wonky. Like, what does that actually mean? What do you do in a day?
I'm work in IBM Research. So we're one of the actually the last standing kind of big industrial research labs of kind of the Bell Labs kind of mold. So it's about 3,000 people globally, working across a variety of different areas. AI is obviously really big, but there's also quantum, where IBM's a leading player. And I'm responsible for all of the large language model, generative AI technology development. So building IBM's own large language models, and then some of the adjacent technologies involved with those. So I have a global team. We're spread across the US, Japan, India, Brazil, a bunch of places. And we build technology and think ahead, both deliver technology that we ship that powers a lot of our products, but then also look ahead and ask where it's going and is it going in the right direction and should we be doing something to steer the ship in a different direction?
No, fair enough. So how does this fit into like Watson? Because one of the things that I'll say, it's kind of funny how AI has blown up in the past couple of years. Because I remember being really excited about Watson in like
Mhm.
2012. I went to Interop, New York, and they were talking about Watson was going to be our doctor. And they sold me, man. Your people sold me on Watson. And then what happened to Watson? So when you're doing AI, are you part of Watson? Is Watson something entirely different? Where does Watson
Okay.
fit in? It
Okay.
doesn't.
Well, so Watson, you might wonder even where did that even come from? So Thomas J. Watson, founder of IBM, and then there's the T.J. Watson Research Center was the research center where they did the initial Jeopardy, sort of beat a human champion at Jeopardy. So that's where the name came from. It was kind of a cutesy, like, oh, this is Watson, this is the T.J. Watson Research Center. I wasn't in IBM at the time. I was actually, I should say, I'm a recovering academic. I was a professor for 10 years at Harvard. And this is kind of like my first real job. And my mom's really proud of me that I finally got out of school. But she doesn't know that I'm actually on the MIT campus. My office is actually right here in a building owned by MIT. But leaving that aside, I was an academic watching it from the outside in, just the same way you were and everybody was. And I remember being impressed by the technology, but also like, okay, this is good. This is like a really interesting milestone and all that. And then, what happened as these things happen sometimes, like, the marketing people took it and ran with it, and pretty soon it was going to do lots of things. And I think there's actually a really interesting theme there, and maybe even a lesson for today around, sometimes technology is really hard. Like we all know that technology is really hard. And one of the hardest parts of it is knowing what you've got and knowing what it can do and like seeing its weaknesses and strengths. So it was really cutting edge technology for the era. I mean, it's hard to even imagine it was not that long ago. It was like 2012. I mean, that's not like it's the 1800s or something, but but it feels a long time ago now. And I think they had a little bit of like this issue that I think everybody struggles with anything AI, where it's like you see it do something amazing, and then you assume that it can do all the things like to the left and to the right of the amazing thing, because if a human could do those amazing things, we'd be able to do the things to the left and right. But these aren't humans. And actually, one of the persistent problems we have is that sometimes things that are easy for humans are hard for machines and vice versa. And I think everybody probably learned lessons about like how to reason about, what you can do and what you can't do, and how do you sell it and how do you not oversell it. So, Watson, that was the thing, they also picked one of the hardest, industries to break into. Like they chose healthcare. I started, and before I came to IBM, I started a healthcare AI company. We created a system which now runs on a huge number of mammograms every year, catches a lot of cancers that might not have otherwise been caught. It helps make the whole process better. We sold that company. It's the hardest industry to operate in. It's regulated beyond all belief. It's got lots of like people care, like particularly things like women's health and breast cancer. People are really passionate about it. So, the idea that AI is going to waltz in and just sort of like reinvent, the gnarliest of gnarly enterprise, might not have been the right choice. But, these are business decisions, and I think, that chapter kind of got closed off at some point. So there is no Watson organization in IBM per se, but they do brand the current technology in generative AI, Watson X. We put an X on it. It's like new and fresh. There's a lot of brand equity. People like a lot of the customers who use Watson. So Watson kind of evolved into a suite of AI tools that were actually pretty good. And this is in the pre-LLM days. And, people liked them, customers liked them. They had good experiences with them. They kept wanting to buy them. And then so they said, okay, we're going to make this pivot to generative AI because everyone's going in this direction. They wanted to keep the brand. So they kept it, but they extended it. I'm in IBM Research. We deliver our products to Watson X. They call products Watson X. It's a brand, it just is what it is. That's how companies are. But like obviously we've moved it's been 13 years, and AI years are like dog years, right? Like 7 to 1 or something. So like that was a long time ago. So like there's probably no traces of any like through line of technology,
Oh.
from then to now. There's some heritage there, and there's great people. In fact, some of the people who worked on some of those, like the early Jeopardy thing way back in 2012. Some of them are still around IBM. I've had them in my organization. I probably have a bunch now, throughout my team. So it's an evolution. It's just how things evolve over time. But we're very solidly now into the generative AI world. That's what our customers need. That's what they're asking for. That's what we're building.
So, I mean, is there so because AI, one of the frustrations with AI is a whole bunch of different technologies and then everything gets labeled AI. So
Yeah.
just because Watson was around so long, is there an eagle eye view you can it kind of explain the difference between what would be the difference of Watson from 2012 to LLMs now? Like if that was supposedly
Yep.
AI and this is supposedly AI, is there any similarities or is that just something,
Well, yeah, that's a great question. And the answer is yes and no. Like it's complicated. That's the answer to a lot of these things. I do remember back in those days, I remember seeing Dave Ferrucci, who was the guy who ran the Watson Jeopardy thing that kind of started that whole trend. I remember seeing him speak, and even back then having this, actually people weren't calling it AI back then. They weren't calling deep learning AI back then. There was actually a lot of discomfort early on. It's like, well, AI usually meant symbolic AI, which is a different way to do AI, where you're like writing logical rules and you're processing them and stuff. And then neural networks was what became deep learning. And there's always been this kind of like uncomfortability, especially amongst academics, because they have personal brands, but they don't have like a marketing department. They don't explicitly brand things. So, they were especially uncomfortable. I was uncomfortable with the term AI. It just didn't like, a lot of what we actually called a lot of things machine learning back then, even, you know, before that term came to mean something else. So, words, man, what do they mean? Hard to say. Now we're calling everything AI, and by and large, we're also really we're almost making LLMs synonymous with AI. I
Mhm.
think a useful way of sort of stepping back and maybe even drawing that connection between the early Watson and then what we do today with LLMs. Watson was really a retrieval system. That was really what it was about. It was about going, having a bunch of data at your fingertips, pulling it together, cleverly synthesizing that into an answer to a question, which might be complex, which might require you to like hop through a couple different, like I need to know what this is so I can find out what that is. And from that standpoint, a lot of the problems aren't so different. A lot of the, how do we think about this? How do we build data sets to know if we're making progress and evaluate the thing? How do we frame the problem? So much of AI is actually just framing the problem the right way, figuring out how on earth you're going to measure it, because if you can't measure it, you can't make progress. And a lot of that's in common with LLMs today. Like, the same kind of notion of we have a bunch of information at our disposal. We either have to like contain it inside the model, or we go out and we search for it with an agent. We go and like actually make the web search. Then how do you synthesize it? How do you do multi-hop reasoning? Like all this stuff is basically, same old, same problems, new, and new clothing, new sort of solutions to them. But obviously we've made a ton of progress, as a field. Like we're doing things that I've been basically studying AI in one form or another my entire adult life.
Yeah.
I wouldn't have predicted early on that we'd be where we are today. Um, so it's been really, really fast. It's not perfect yet by any stretch, and you have to be very careful, using it, thinking about how you're going to use it. But it's also very powerful, and obviously it's going to change a lot of things.
Okay. So with IBM's like plan or strategy or how they're doing things. So I have a buddy of mine who's a COBOL. He leads some global team for IBM. And one of the things he talks about is, I guess, mainframes or IBMI. I don't quite, there are a whole
Mhm.
bunch of names I don't ever have to deal with.
Mhm.
Apparently, they still make you guys bank like lots of money. So when you're looking at your AI strategy, for you guys, is it a software and hardware? Because he was talking about how the database is actually built into the operating system, and that's why
Mhm.
it's so solid.
Yeah.
Are you using that same mentality in the AI world, or are you just kind
Mhm.
of breaking off more for software at this point?
Oh no no yeah no and to be clear like if you don't like really like know what IBM does, like you could be forgiven because it like took me 5 years of working here before I like actually like felt like I actually knew what we do.
Yeah.
But we do a lot of things. We help our customers with their information technology, right? And that could be everything from hardware systems, and we do make a lot of money on hardware systems. 70% of the world's transactions by value pass through our systems. If you swipe a credit card, 9 times out of 10, that's going through an IBM system because they are just incredibly rock solid, built to purpose for that purpose. And then we have all kinds of other software to help with data and other things. We have a consulting division that helps people implement these things. So we're a big company, but we're not like, there's like these Japanese holding companies where it's a chemical company and a rubber company, and they also have a healthcare division. It's like what? It's like what is that company? We're not like that. We have a focused, like we're going to help companies deal with their information technology, like all the systems that they have. So, we do, we have, a lot of software that's, makes a lot of money. We own Red Hat, which makes Red Hat, the Linux that sort of powers enterprises, Red Hat Enterprise Linux. And, the consultants kind of pull it all together. There's a couple dimensions to the question of like, well, how does this relate to like maybe even the hardware? One is that we're enabling AI on those mainframes. So those mainframes that are, processing 70% of the world's transactions by dollar amount, they are now right on the chip that powers those mainframes, which is a technical marvel. It's like one of the most advanced chips running at a super fast clock rate and like super like 9 nines of reliability. The thing is only down for 34 milliseconds per year of downtime. So just incredibly resilient. But they're adding AI. There's an AI core right on that chip, which can help process. unstructured data, look at, in transaction, you can actually look at some of these things. And then we're also rolling out, external accelerators so you can do more AI in the context of, hey, like, Eli just made a transaction, is this look sketchy? Like, he's on upstate New York and, he just swiped a credit card. Like, does that make sense? Is that consistent with his behavior? Some of those things we can do now with AI that are right there in the hardware, and that can save a lot of customer pain because it's always frustrating to me whenever one of my credit cards gets declined because I'm traveling. I travel all the time. I wish they would figure that out. Like it makes perfect sense that I'm that I'm in Paris right now, but that kind of thing, and it saves a lot of money because fraud's expensive, and you can also look at money laundering, all kinds of other things, and not just the financial sector either. Like every sector of the economy, everyone who does work, kind of they're our customers by and large. So lots of opportunities, even at the level of that those old systems, not old systems, they're brand new systems, they're really advanced systems, but they're running COBOL code from, that's been in continuous development for decades. But now we can bring it into the AI world and do more sophisticated things. Now, at the same time, you could ask, okay, well, that like, huge number of nines of reliability, is that a grounding principle when we kind of enter into this Wild West world of generative AI and large language models? And the answer is it is. It's like, IBM is the kind of company where we're not going to do something like super edgy and like makes you uncomfortable. Like our whole brand is about trust. So when we build large language models, and these are the ones that we, power AI features in our own products, our customers have them, they're open source as well, anyone can use them. We have millions of downloads of these now. Not as popular as some of like the household name models, but they're out there. And really what we're focused on is how do we make them as transparent as possible? Because LLMs, large language models are kind of like, it's like one of those like you are what you eat kind of things. They are the data they were trained on. And there's a weird like convention or just fact in our field that most of the model providers won't tell you what data they put in them.
Yeah.
And you might wonder why they won't tell you what data's in them. We just say, okay, here it is. It's all there. We'll tell you exactly what's in these models. They're transparent. We'll stand behind them, like the full faith and credit of IBM. We'll indemnify their use, in various ways. And that's what our models are. They're kind of like the suit and tie buttoned up, dependable, like, the kid in school who was the Boy Scout kind of like that. That's kind of the vibe. And of course, we enable customers to use any models they want, any, open model. Our consulting folks work with any model, even proprietary models. If it doesn't, it's not like we're insisting that they have that level of transparency and trustability, but we want it to be available as an option, right? Like customers should have that option, especially in regulated industries like healthcare, like financial services companies, where regulators might want to know that stuff too. So that's really how that kind of plays back and forth across time. We want to be dependable.
That's good. So that's interesting though, because that's one of the things that comes up with the open source models where I have questions.
Mhm.
So the data set your model, so like Granite's your model,
Mhm. Yep.
right? So the data set that Granite is trained off of, can I actually download that from somewhere? I can see that data set.
You can't download that. So we've distributed versions of the data set. There are interesting complexities around what we're allowed legally to redistribute and things like that. We do actually we have distributed a data set. We have a data set called NiceWeb, GNEISS. It's like a rock joke. Nice is a kind of rock like granite is. Anyway, we made that available. It's like it's not a data set. It basically is like a filtering operation that you can download something and then it will tell you which parts to keep. It'll transform that existing thing into what you need. So from that standpoint, we're distributing it. We just like require you to get the thing yourself from the original source, and then we'll tell you exactly how we curated it. And the curation is really important because that's the whole game. Like it's not about how much data you just shovel into the thing. It's about how
Yeah.
much quality data you shovel into the thing. So it's the entire game has basically shifted to like how do I get the right data and the right mixture of data. And so we're just completely transparent about the sources. Pretty much all of it you can just go out there and download. There's no mysteries. There have been cases in the past where there were data sets that were identified to be just like they call them shadow libraries. It's like piracy. It's like there's somebody just collected up a bunch of books without permission, put it in there, and there were models that were including that as training data. It was actually a very popular thing to include, and that's the kind of thing that we just don't do. It's just like we'll tell you completely what's out, what's in the model, and then you can recreate that data yourself. We give you all the tools. We've open sourced the tools so you could recreate exactly what we have. And then at that point, you know the important details of what's there. The contrast is that these open weights models, they're not telling you what's in the data. They're not telling you how they made it. So it's kind of like they just left a big pile of, billions of floating point numbers on the table and said, "Hey, it's open." It's like, okay, you could take a binary of Windows, and put it on the table like that. It wouldn't make it open. So that's kind of a tension in the field that we're kind of not, we haven't kind of worked through it yet, like how the field feels about open and what really is open and not open.
So I guess, yeah, that's one of the questions. So for me, being like a Gen Xer tech person, like, so for me, open source was Linux and
Yeah,
OpenOffice,
yeah,
that
yeah.
kind of.
Mhm.
That's been one of my questions is so I hear these open source models, but the open source model is just the product of the everything it got trained on.
Yeah,
So if I have no idea what the hell it was trained on,
yeah,
I don't really understand what the verbiage of open source actually means at that point. Like, is that
yeah.
like if I have an open source model, but I have no idea what it was trained on,
Mhm.
does that actually do something? Because like with Linux, I can go in and modify it.
Yeah,
But if I
yeah.
have a model, but no, can I do something with that model, like realistically?
Yeah, yeah, I think you're hitting the nail right on the head. And I think a lot of people are exploiting the fact that, words can mean multiple things. So if people are careful, they'll call those models open weights models. So the weights are the things that are adjusted in the course of learning. So it really is just like a big file with like billions of numbers in it. And those numbers, you can look at them, you can sort of probe the model, but you can't really be sure what
Yeah.
went into them. That's causing some concern when there are companies in other places where you might be concerned that there's nation state influence and you're really just not sure what's in that model. And lots of companies aren't comfortable using those models because it's not like open source software where you just look at it and you're like, hey, I can see there's a security vulnerability there. It's there for everyone to see. Somebody can scan through it, find it. Like we know that open source can be more secure than closed source in software. But you're right. An open weights model is much more, the model itself, just the weights, is more like a binary. So like we compile the source code into a binary file, and that's what you actually run. It's written in machine code. Nobody can understand it easily. And you couldn't reproduce it. You can't fork the project. You can't make your own version of it and take control. So it doesn't have any of the properties of open source. Now, interestingly, so OpenAI just made waves because they released an open weights version of, they released a open weights, an open weights model. And then it's like, okay, great. Like OpenAI is actually being a little bit open for a change. That's weird. But then they called it GPT OSS. And OSS, as you know, is open source software. So it's like, man, they screwed it up still. Like because there's nothing there's no software.
Yeah.
It doesn't really meet the definition of open source. Open source would imply that if I didn't like the direction that OpenAI was going, I could fork the project, I could make it my own, I could give it a new name, and I could go run and do whatever I want with it. So it's more like as if Windows had like released, like given a binary for free of some like, couple versions ago Windows and, to undercut the market perhaps, or, like, and actually there were versions of that back when Windows and Linux were sort of, in a fight for the future of the internet, right? So, whether that's disingenuous and cynical or that's just like they really are don't know like what the words mean or they don't care or maybe OSS is a different acronym that means something else to them.
Yeah.
It's not clear, but you're right. It's like these open weights models aren't really open source. And I think the issue is going to be increasingly forced, where if we're really gonna have an open versus closed, you know, sort of battle for the fate of, the future, not battle, but like, if we're gonna do what we did for Linux, I think the world is much better off because Linux won. And, like there was a time, and, I'm also a Gen X, computer guy. There was a moment, you probably remember, like where there was a chance that it was going to be like Windows NT running the
Yeah.
internet. And
Yeah.
that, I mean, I when I was in college, I remember I administered some Windows NT system with the database. Like that would have been terrible. Like because it's the collective creativity of everybody, and everybody feeling like they can invest and make it their own. And if they had to, they could really make it their own and like fork off their own version of it. That's what makes the internet really work. And that model is so powerful. Like all of the founding infrastructure that we build software on is all open source because we recognize that software is really hard and we can't do it alone. So everybody has to feel comfortable to invest and build the stuff that's not competitive. Like the operating system, everybody needs it. Let's all contribute to it, make sure it's great, make sure it's secure. And that works well. And it doesn't mean you can't make money. Red Hat as a company founded on, putting a layer of sort of extra, services and expertise on top of Linux, and they sell and make a lot of money. So it's just a very powerful model, and it's not clear that which way it's going to go. Like we're in that moment now with AI, and I think AI is going to be as transformative as the internet was.
That's right. So is there, because that's the thing, like I remember back in the day when it was still an argument over open source. Like the weird thing about doing YouTube videos and doing
Yeah.
this for
Yeah.
30 years is there's the way you see the world and then there's the way the 20-year-olds see the world, and it's different. So I remember like learning about open source and having my instructors literally say, this is an argument. Is it free as in free speech or free as in
Yep.
free beer? And that's what I learned about open source. So when I started doing YouTube videos, I talked about that. And apparently the open source initiative had come out and they had come up with rules about open
Yeah.
source. And so I was wrong now. So with these AI, so have you seen or are you guys working on any kind of these licenses, like an Apache type license just for AI models? Is there something like my viewers could say, oh, it has this license that means something? Is there something like that coming down the pike?
Yeah, unfortunately, I mean that there is work to create new licenses for AI.
Yeah.
It's just kind of tricky, right? Because I mean, so we released our models, all of our models are released Apache 2. And what Apache 2 license says is just, hey, here it is. Like we're not going to like give you any warranties that it works or anything. It's just here it is. But you can go and do anything you want with it. If you want to build a proprietary product with it, if you want to just resell it as is, go in peace. Like you have complete freedom, within some very reasonable limited bounds. Apache 2 and all those licenses were written for software. So, as we were looking at it, we talked to, the folks at Red Hat who, Red Hat is a company that's a subsidiary, basically a wholly owned company of IBM. We asked them for their advice and they basically said, well, yeah, it's like kind of not maybe the most perfect thing. It wasn't kind of made for this, but like everybody gets it. They immediately get that this means like no restrictions, like go in peace, do business. It's all good. And that's what we did. And we weren't the first. Mistral did the same with their models. And everybody's been kind of going back and forth on these things. There are licenses that are custom, but they tend to be restrictive ones. Like if you have a model built from Llama, you could further tune the weights and make something that's your own, but then there are restrictions on you have to include Llama in the name, or there's other terms in the community license. People have also tried to put license restrictions on you can only do good with the thing, or here's some activities you can't do with these, and you can't usually guarantee what your customers are going to do with some things. So like those have kind of gone in and out of favor. But the real issue is the source code, right? Like if people aren't releasing the source code that you would use to make it, then can you really make it or not? And at that point, then you're talking about putting open licenses on software. The problem is that these are incredibly expensive to make. I mean, you need to have many millions of dollars of of hardware, of GPUs, of servers. You have to be able to wrangle all that stuff to build one of these things. So even if somebody put out the code for it and gave you the weights and gave you all the data, it's still like a tricky proposition because it's just a really, you know, capital and operating cost intensive thing to be playing in. So, I think it's an open question too, like how that's going to evolve and what it means to be open. And there are other industries that have huge capital costs, like the semiconductor industry. Like you have billions of dollars to build a fab where you make those chips. It's just like steep. It was like there's no way to do it in the open because like who's gonna what are you gonna do? Like it's a huge investment. It's got lots of like trade secrets and stuff. So it may be that large language models and AI go that way, that there's only a few players that actually make these things and can afford to make them. Or it may go more the way of software, where we actually have open licenses, we have communities that collaborate. I think the open version is always better because it means that more people can participate. You can get different viewpoints. It's not like a one country or one company's point of view on something. It's powerful, and it puts the users of the model back in control to a large extent of where the technology goes. And I think that's important.
Yeah, fair enough. So then with IBM and with what you're doing, so one of the weird things with IBM, I don't really get what IBM's doing. I've followed you guys for years. I'm so confused.
Hmm.
So like when you're thinking about the people, so you've open sourced Granite and it's supposed to be a really small model and it's supposed to be great. So people like me or my students should be able to use Granite and have fun with it.
Yep.
The weird part about it with IBM is IBM seems to swing between being wanting to be super corporate, for most people can't touch it, to
Mhm.
going and buying Red Hat and being incredibly like everybody friendly.
Mhm.
But then don't want to get into it with IBM politics with you. But then they start locking down Red Hat and doing some really weird things
Mhm.
with Red Hat. And so like when you're thinking about the people that you think would be deploying and maintaining these kind of like IBM type systems, like where do you think there coming from? Do you imagine a startup in their garage using Granite or IBM AI to build their thing, or is this like government major corporations? If you don't have $10 million, we don't want to talk to you. Like where are you thinking?
Yeah, well, I mean, so one thing with Red Hat, I mean, IBM largely leaves Red Hat alone. They actually operate. It's interesting. We've had some collaborations with Red Hat and I even had a badge where I could go down to the seaport and like go to their office and see how different it was. They have a completely different culture.
Mm.
So I don't think they've changed that much. And their customers are enterprise. Actually, that they're kind of an interesting case because I think it answers your question a little bit, where you can kind of be both, right? Because, you know, one of the reasons to be open in an area like AI is that there's people who build applications with large language models. They kind of have the models and the software they use during the day, and then they have the models, at night, like their hobby stuff, like the models after dark, as it were. They have a little passion project, or they're contributing to an open source project, and they have these kind of two personas where it's like, yeah, you probably have to buy a solution that's like enterprise grade. It's going to be secure. You're going to have all these guarantees and certifications and stuff. But the technology selection, your technical people are going to make decisions about like, hey, should we use this thing or that thing? And if they're using that thing at home, or if that thing I can just download it off the internet and kick the tires and get a feel for it, then when you need the certifications and the guarantees and the industrial grade scalable, it's going to go from your laptop all the way up to huge mission critical deployments. Then you want to move from that open source world where I'm just hobbying to like industrial grade. And I think that's the reason why it's so important to work across that spectrum. I mean, obviously, where we make money, where we, where our focus is first and foremost is the customer, and that's business of all sizes. But certainly large companies are big IBM customers. But we need adoption. We need developers to use it. We need developers contributing to healthy open software. Red Hat has Red Hat Enterprise Linux. That's like no normal person would use that at
Yeah.
home, but you would
Yeah.
use Fedora, which is their sort of hobbyist grade one. You get none of the guarantees. But you get in the ecosystem, you're using your package manager is the same flavor as what you're gonna, roughly speaking, get with the enterprise version. So that's kind of the bridge that we're playing. The worlds that we're bridging across. I think we're also undergoing some transition, right? Where like IBM's a 110 plus year old company. So like you can't be a technology company that's been around for over a century and not reinvent yourself constantly. So we're always, changing a little bit the formula and we're kind of again reinventing ourselves. Some of those parts though are actually quite old. Like Linux, IBM was a huge supporter and element of the success of Linux because at that moment when we were asking, should the internet be built on proprietary things or should it be built on open things, we basically poured a ton of investment into helping the open thing win and together with others in the industry and making that possible. So, people, there's a lot of value in having open source projects, not because we're philosophically necessarily like there was kind of like the Richard Stallman kind of like ideological version where he's like, it should be free because, it's like almost a moral sort of imperative that it be free and open. But then there's a version of it which just says like, hey, it's just good business sense to have this be open because this is something we need to share the cost of development across multiple players. It's not competitive. We're gonna work together on this. Um, it's going to be more secure that way. And that's a philosophy we've had for a very long time, it's dating back to Linux. And that just continues today. Like, hey, we're building our products with lots of open source components. We want to contribute to those projects so we have some influence over them so that we're sure that it's going in a way that meets our needs in addition to everyone else's. That hasn't really changed. And, from the outside, yeah, maybe it looks like one thing or the other, or but that's kind of a through line for IBM.
Okay. So, like the technologies you're building nowadays, it's something that more people could actually get their hands on. Because I think that's one of the things is
Yeah.
like just in the past, like I say, my buddy who does COBOL, I mean, he's desperate for COBOL employees, but
Yeah.
like if my students want to learn Python or
Yeah.
JavaScript,
Yeah.
Node, I can get them there. I
Yeah.
literally have no idea how to get them down the path of COBOL. So with
Yeah. Yeah.
AI world, you're a little bit easier than
Yeah.
that.
Yeah,
Yeah.
they'll make good money if they do manage to learn COBOL because the COBOL developers are in high demand. But
Yeah.
yeah, you want the technology to be accessible. You want it to be like you need a community around it
Yeah.
because you need to be getting a kind of feedback that you're gonna maybe not get as readily from an enterprise customer. And it's really just about creating a thing that's like it's easy, it follows all the sort of fast-moving pace of open source and startups and all that. But then it needs a progression path where if I'm going to deploy this and it's going to be like running, the tax authority of this country, it better be bulletproof. So it's really about just sort of bridging that gap. And that's 100% why we play in the open, because it's like we want to make sure that there's always an ecosystem that's healthy in AI and other fields. We contribute to lots of open source projects. So we're big contributors to PyTorch, for instance. And that's all part of the whole ethos of how software gets built.
Yeah, okay. So in your world, so your departments you're dealing with, like who are you hiring? Are you hiring comp sci majors? Are you hiring people out of boot camps or self-study? Like, will Python get you a job with you folks of some degree? I don't know.
We hire a wide range of folks. I'm in IBM Research, so the vast majority of the people who work in our organization have PhDs,
Yeah.
usually in computer science, but statistics, physics, all across the map. So, but we do have quite a few engineers. When it comes to hiring engineers, I care much less about what their degree is
Hmm.
and more about like what they've done and evidence that. So I would never like we have lots of PhDs, but that's largely because if you're inventing new technologies, constantly and everything is all bleeding edge, it's very hard to to get that level of experience unless you've gone and like spent 5, 6 years just dedicating your life to it and getting that PhD. But for engineers, like we hire from all over really, because it's like it matters what you can do, not you know. I mean, that would be true of a researcher too. It's like a really hard thing when the field is this new and it's like coming right out of academia. That'd be
Yeah.
pretty hard. Now, across IBM, we hire, we have, tens of thousands of developers and they hire those, across the spectrum. And again, it's really about what they do. And I can't comment on their hiring practices, but that's kind of how we end up working.
Interesting. So again, so with you, because I looked at your background, it was weird. So you graduated from Harvard with
Mhm.
a biology and a psychology degree, and then you graduated from MIT with a PhD in neuroscience.
Mhm.
And now you're doing AI. So do you know how to code? Do you know what a function is? Like,
So I was a computer science professor before I was at this job.
oh, okay. Yeah.
And then I started two software companies, one of which now runs at the same scale as the National Health Service of the UK. Like we were millions of mammograms. So yeah, I've written some software. I also my lab produced Triton, which is now OpenAI Triton. That's the kernel language that like basically it's how you accelerate LLMs if you're not using NVIDIA's tool set. So that's an open project. So yeah, so I've been like so my resume has never made any sense because I'm
So
too
where is that then? So you get a degree from Harvard, a PhD from MIT, and then you're
yeah.
like, oh, I'm smart enough to also co are you just really
I've been
smart?
coding since I was 3. I kind of like learned to code and read at the same time because my dad brought home a computer from his work, which was this big thing. So anyway, like again, like this is part of the reason actually why I don't care too much about what people's degrees are. Like if you're writing code and that code's getting used, then like if you have an open source project and people are using it, like I have like multi-hundred thousand line code bases that I wrote when I was in grad school that are still in continuous use, funded by the National Institutes of Health and like so like and we have a couple we have two open source projects that got pretty wide distribution. And then, you start a few companies as well. So yeah, no, like I don't think like I think especially in AI, you look at some of the early Google Brain employees, for instance, like at the very early days when people started getting excited about deep learning, I was kind of hanging out in Mountain View a fair bit back then. And it was weird because there were a lot of neuroscientists in the mix, a lot of physicists too, where they're like like there wasn't like a well-defined discipline yet. So lots of people were coming in from outside. It was kind of like, that like bar on Tatooine where it's like all these different alien creatures kind of like hanging out. Maybe it's a little sketchy or something, but like it was a lot of different people who just had like an interest and a passion for this. There's actually a lot of neuroscientists who found and by the way, I was a computational neuroscience student, so not neuroscientist as well. So I was actually building like early like vision models and things like that. That was where I was coming to it from. But there are a lot of neuroscientists in the field, partly because they're in the business of like trying to understand, understanding, if as it were. Like they're trying to understand the natural. That was the thing. Usually, a computational neuroscientist is like, I'm fascinated by the idea that we have this biological computer in our heads, and I want to figure out how it works. And then it's very easy to fall off the edge and be like, okay, but I can just build it faster, and this is moving. And then, so I ended up sort of switching from neuroscience. My PhD was probably half and half, like actual wet lab neuroscience and then computational neuroscience. Then, as I got my own lab and started my own academic career, I kind of had both sides. So I've actually probably graduated more computer science grad students, many of whom now have their own labs. They're professors at various places like Notre Dame and Oxford and whatever. But then there's also like wet lab neuroscientists who went off and became, basically they're in biology departments and things like that. So it's a little bit schizophrenic, using the colloquial version of that word, not its like actual clinical meaning. But it's like I'm just a curious person. I can't stay in one place for too long, so I kind of just follow what I'm interested in. right now the interesting thing is definitely AI.
Oh, interesting. So was there anything that guided you? Because I think about that, because like, people think I got my degree in comp sci and I actually got it in criminal justice. So like,
Oh,
well, again, Gen X, like we didn't do that, like none
yeah,
of
yeah,
this
yeah,
existed.
yeah, 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 yeah.
So like when you were doing bio and psych, and then when you started with neuroscience, was somebody guiding you? Was there like mentorship? Was there a path, regardless of where you got to where you thought you were going? Was there something you thought you were following, or what got you down that kind of like that educational path?
Yeah, like I there, of course, there are always mentors, right? Like everybody, nobody gets anywhere unless you have like people who kind of like help you, like just help you, like understand the lay of the land and all that. But like if I could make up a story, I could like retcon like a rationale for what I was trying to do. But like I was just following what was interesting to me.
Oh,
Like I applied to and got into medical school and then just decided not to go and I went to MIT instead. So like was like I thought I was going to be a doctor at some point. Like okay, fine, I'll go and get into medical school. But then it was like, is that really what I want to do? There's exciting stuff over here. So I've just really honestly been following what seems interesting at any given moment. So and I guess that's the advice I'd give to people. It's like, well, yeah, find good mentors, find people you trust who like care about you and will give you good advice. And then evaluate that advice. Feel free to ignore it because like there's no reason you need to have a conventional career. Like if you're passionate and you can really, you really put in the work, you can kind of move around as much as you like. And of course, there's tactical advice, that matters about degrees and things like that. But there's just too much interesting stuff going on that you can just, and everything's changing so fast too. Like what a computer science degree is now versus what it was 10 years ago is also very different. So I don't know.
yeah, fair enough. So then with MIT, just looking at the MIT, one of the things I thought was funny is a couple of years ago, for whatever reason, I just ran into a lot of like 1980s, 1990s MIT grads.
Yeah.
Oh, oh my God, disabused me of the notion that MIT was a good school. Like I was surprised and trashed, like just trashed MIT. How do you like I was just sitting there like drinking a beer, like, are you allowed to say that? Wow. Like, so especially nowadays, like we hear this, like if you don't get into an Ivy League school or whatever, we hear this across the board, like you're just
Yeah,
screwed in life.
yeah,
Like, is MIT, maybe MIT has changed. Maybe I was just with disgruntled people. Like, is getting like a PhD from MIT like the gold medal standard? Like, is,
yeah,
or is that just, whatever?
yeah. Well, I'll say this. I've been inside MIT and Harvard both. Big a brand as you get in sort of U.S. universities. It's kind of the best of times, the worst of times kind of situation, right? Like, I mean, MIT. It's tough, right? Like they're hard on the students, like they're rigorous, and like a lot of people come away from it not. This is the undergrads, right? Like the grad students, we're just off doing research. It's a different sort of story. But I think a lot of people come away disgruntled by it. I also think that there's lots of universities, like colleges, actually, like small liberal arts colleges, or even small technical colleges, where they really focus on the teaching, and the teaching is just better. Like it's not necessarily the priority of some of these big research. They call them R1 universities. Their
Interesting.
their biggest focus is doing great research, and then the teaching kind of happens as a consequence of that. So there are a lot of people who I wouldn't recommend going to a Harvard or an MIT, even though those are the places that I went, and I met my wife there, and all that stuff. But at the same time, if you're really going to take advantage of what's there are faculty and other students who are also drawn to the same thing. And the interactions you can have there and do research can be amazing. If you just go to like take classes, you can have some amazing professors, but you can also have some very uneven experiences. You can be very stressed out. And every place is going to have something like that. But at the same time, like, like when I recruited grad students, when I was a professor into the program, when I hired in startups, when I hire now, there's a lot you can play Moneyball, right? Like it's like, yeah, there's a person with a fancy degree, and sometimes they are indeed brilliant and they have incredible experience. But there's also a lot of people who don't have brand name degrees. I actually really like hiring those people because you can just like you can see that for whatever reason they got started late, or they just like that wasn't important to them or whatever, but they just have a spark and they're really fundamentally good. And I'm not saying that we get them like on the cheap or something, but like we pay them the same. But like it's that we aren't competing, like other people aren't seeing the sort of spark all the time. And those are some of the best hires I've ever made,
Huh.
like the hundreds of hires now that I've made across my career. Some of those are some of like the ones I'm like happiest with and proudest of. But, at the same time, on average, you hire an MIT grad, they got a lot of publications and top, AI conferences, they're probably going to be pretty good, also. So I don't know. It's a little bit of like the kind of students that I'd get at Harvard when I was a professor there. You could almost like put them in a dark room and beat them with sticks 3 times a day, and they would still come out, very polished and like having learned a lot because they were just intrinsically sort of driven that way. And it's just like a selection bias. But, when you have people who, I don't know, again, it's all about what you do and demonstrate that you know and that you can do. And degrees aren't that important. They're kind of a convenient crutch. I think sometimes we fall too much on.
Huh. Fair enough. So, in talking a little bit about models, so we all talk about LLMs now, but there are going to be so many acronyms. So, there's LLMs, multimodal models, reasoning
Mm,
models, plus about
yeah.
20 others at this point.
Yeah.
Can you give like a brief idea? So, are these all, so it all goes through a neural network and it's all doing statistical stuff that's way above my head. That's for you people. When I get the model back, like, is an LLM fundamentally different than like a reasoning model? Like, is this just a file that the data filters through? Like, what am I kind of looking at with like when we say model, I guess that's the thing.
Yeah.
But model, what is a model? Like, what are we talking
Yeah.
about here?
Yeah, that's a great question. I don't love all those acronyms. Like, I'm actually quite happy with LLM. Like we could have just stuck with just that one for the most part. People have
Yeah.
started calling LRMs large reasoning models.
Yeah. Okay.
Like
Yeah.
it, like the exact same, you know, set of weights, like the architecture of the model, like everything about how you run inference on it could be exactly the same between an LLM and an LRM. The LRM just does this thing where it like thinks out loud for a while.
Yeah.
It's a model that does a particular behavior. So I don't love that acronym because it kind of it's like giving a name to something that's not different enough in my mind. People also say SLM, small language models,
Yeah.
which is on the other hand is kind of ridiculous because like this is like a 8 billion parameter model. Like
Yeah.
not really small. That's actually like, gigabytes of large. Like I was training like in grad school and in undergrad, we'd have like 10,000 parameter models. Now we're talking about billions of parameters of models, that are trained on tens of trillions of data points. So, small and large, whatever they're sort of relative terms. But what they are at the end of the day is, the file you download
Yeah.
has sort of it's a bunch of numbers. And what it's doing is just doing like multiplications and additions at the end of the day. And, a few other very, very simple functions. And then the key thing is not the structure of how it's put together matters a little bit, but it's really about like how did you get to those numbers and what do they do at the end of the day? And the reason it's called a model is because it's like a model, you're modeling something. There's like a distribution, like there's some things, that you would say are more likely and some things are less likely. Like if I speak fluent English and then my words are sort of predictable from one to the next. If I say the cat and dog would be a very likely word, but albatross might be less likely, and table, or a word that's not a noun, like it's syntactically incorrect, like the cat and justice, like justice is another noun, but like cat and runs, like it's syntactically incorrect. That's not very likely. What these models do is they model the probability of what it should say. And the reason they can do things is that you can sort of sculpt the probabilities such that you can start training them to do things like, answer a reasoning question or a logical question, and they'll actually come up with the most probable answer based on what the training data they've seen. So you can actually train them to start doing stuff, which is pretty cool. But the word model goes all the way back to the beginning when we were actually thinking about modeling, the likely outcomes and, probability distributions. But I think it's a confusing word for the general public. Like none of these words were made for, for regular people to make sense. That there's a lot of history to them and kind of is the way it is. But yeah, big pile of numbers. They just do simple math, but it's a lot of simple math that was constructed in a very interesting way that, you can have little conversations with them at the end.
All right. Well, especially with GPT-5 just coming out, one of my questions, are we focusing or are we being told to focus
Hmm.
too much on these models? Because I just had
Yeah.
the last interview, maybe the interview before
Mhm.
last, contextual AI, and he got $100 million to create RAG 2.0.
Mhm.
And so that's the interesting thing. Like we talk about AI, and so much just nowadays becomes LLMs and models. Are we
Mhm.
focusing too much on that and not enough on an overall intelligence architecture with RAG and other
Mhm.
systems and services included?
Definitely. Yeah. And actually, I think it's even bigger than that. I think we're losing sight of the fact that this is all just software at the end of the day. And
Okay.
this is actually Clem, the CEO, founder of Hugging Face, big player in the open ecosystem, had a quote which paraphrases basically to when it works, it's software. Like it's like once it becomes like everyday and routine, then
Mm,
we it stops being kind of exciting. Then it's just then we just treat it, we just say it's software and it kind of disappears into the background. And I think we're going to get to a place where we get there. And this is actually one of the things that we're driving really hard because right now, like the way we implicitly interact with these models is we treat them as if it's like a little digital person or something, and we talk to it and it
yeah.
talks back, like, which is, you speak into the void and the void speaks back. It's like a weird model when you think about that in terms of software, because it's like your mental model is I opened up like a DM, like SMS message stream, and I'm streaming messages back and forth. But the reality is that these things are actually kind of like computers, right? Like you can give them instructions. They aren't written in machine code or in Python or anything, but they're written in natural language and they can operate on data. I can say, summarize this document in 100 words or less, and they'll actually do that. So that's cool, but then like if it's going to really be software, there's a lot more that you can do. Like you actually really like start bringing computer science principles to the table. You can start changing the way they operate. You can analyze and say, if this is a computer, what kind of computer is it? And it's actually we've done that, started to do that work, and it's a very interesting and weird computer when you see it through the lens of computer. So I think this is eventually going to become something that just becomes part of the air we breathe in software engineering. It's just another way of another kind of function that we can call to help us solve things that we don't know how to write the code for. And I don't mean they write the code for us, but like if you wanted to like analyze what's in a picture or you wanted to like summarize a document, we don't know how to write the code to do that, but we
Yeah.
can do it with this kind of magic, generative AI computer that we now have. And I think the reason that this is so important is because even those like super frontier models, they're very expensive, they consume a lot of energy. Even those developers, I think, are struggling to get them to do what they actually want them to do. And
Okay.
that's partly because we just don't have like a like actual software engineering discipline, all the stuff you'd learn if you got a computer science degree, like about, encapsulation, abstraction, um, you know, thinking about complexity, like all of that is we're kind of YOLO and like it's just like, hey, talk to the magic leprechaun in a box and it'll give you the answer back. It's actually the case that oftentimes, one of the things that's most remarkable, sometimes I'll say something like, the second most interesting thing or remarkable thing about LLMs is that they can understand and produce natural language fluently. And then the
Yeah.
most interesting or remarkable thing about them is that they're like, wrong between 5 and 50% of the time, or they'll do the wrong thing or do something different than what you ask them to. There's something about like they're amazing, but they're also like even the very best models, the biggest models are kind of strangely unreliable.
Mm,
And what we need to do is we need to like that's not a new thing. Like if you have, a car these days might have a dozen computers in it that are
mm,
all operating with like real-time operating systems and all that. They can't be arbitrarily reliable, but you build software that kind of is resilient against failure, right? Like there's redundancy and there's mechanisms to know when you made an error and be able to recover from it. And I think by and large, that's what we need. We need it. We need more of that. And then I think when we have more of that, then these things will start behaving more predictably. It'll kind of blend into the background of software. We'll just use it just the same way that, once upon a time there weren't databases, and now there are databases. You take them for granted. They kind of disappeared. I think something similar is going to happen with a lot of practical AI.
So do you think, so one of the interesting things I've heard lately is with a lot of the problems with the LLMs, there's a lot of people actually arguing nowadays that LLMs are kind of like a technical dead end. Like
Hmm.
you've been able to go a real long distance, but we're starting to see the edge of the cliff. And so, like when you're looking at it with all of your experience, do you think there is something fundamentally post LLM? Like there's just gonna be like we're just gonna learn LLM was great for the time period, but that was oh so 2025, or is the future more we're gonna get more kind of a platform or operating system where LLM is one component of a product that has 50 components that
Yeah.
gives you that intelligence.
Yeah, I think so. There are prominent folks like Jan LeCun believes that LLMs per se, as we do them today, are a dead end. And yeah, he has well-founded reasons. I mean, we could disagree, and we have. I mean, in various points throughout the years. But um, I think the thing that's going to happen though is like the AI thing won't fizzle out because if a better solution to that problem arrives, then it becomes AI. The king is dead, long live the king. That'll just become what we call the same words at some level. So like if you have a technical concern about it. Now, I do think that, AI has gone through all these boom and bust cycles where it's like, AI winter, like AI summer, and, there is concern that there's too much hype around it. I don't think we're going to have another AI winter because this technology can be made to be useful. But I do think we potentially are running a risk where if people kind of just YOLO and create all lots of kind of sloppy agents, and then these agents are running around causing havoc because they're poorly done and they don't have guardrails on them. And we don't think about the model and the software and the agent and the software around all of that. Then I think we're going to get in trouble, and there might be a little bit of back and forth, natural kind of movement. There might be a little bit of reset there, but and this is part of what we're trying to do at IBM is we just want to build safe systems, responsible structures, frameworks, so that you can use these things, get all the value that we know is there, but do it in a way that's not going to cause, massive disruption, or it's going to cause embarrassing mistakes and things like that. So I think we're going to get past it. I think it's just, I don't think it's going to get solved by GPT-7 or something that's kind of not the point. It's less about the model and more about admitting that this technology is amazing, but it's going to hallucinate sometimes, or it's
Yeah.
going to be a little bit flaky where you change the order or the wording of a prompt that you're using in your agent and it changes the behavior in a weird way that you didn't expect. We're going to need to build a new way of doing software, I think. And I think I'm actually quite optimistic that it can be done and that we're going to do it. And then it's actually going to change how we do software, all software. I don't think we're going to have a separation in the future between I'm doing AI now, here's my agent, and I'm writing some code to do whatever. We're just going to weave it in. It's just going to be like second nature. It's just going to be like, okay, now we have for loops instead, now we have, switch statement, whatever, it's going to be that kind of, well, we have object oriented. I think it's going to be another paradigm and another tool in the tool chest that we have. And I think that's where we're going. But, the other thing is just there's so much noise and so much excitement and, press and everything around it that we're kind of just kind of I think that other enterprise is going to have to kind of quietly emerge while the other stuff happens over there.
Fair enough. So I notice you use the word like hallucination, and I guess I'm part of the like the rebel group nowadays. That's
Hmm.
like it's not a hallucination, it's a fucking error. Can we just say that? Like,
I
how do you no? Because like
hate
there
it.
was
I hate the word hallucination.
what's that?
I hate the word hallucination. I'm
Oh,
with
you
you.
yeah, okay. So how do you feel about those words? Are we using, like, from your level and where you're at, are we using the proper words for AI? Because, like I say, when we say hallucinations or we say even training, it is training, but it's not teaching a kid. It's like
Yeah.
what they're doing in the legal process right now. It just sends me up the
Mm.
wall.
Mm.
Do you think this lexicon, these words are going to change, or is this now so embedded in how people talk about this?
Yeah.
Yeah.
Yeah, I think confabulation would have been a better choice of word. Or, error is a good one too. It's not like hallucination. Actually, one of the things that kind of drives me nuts, like given my weird background, like I was a card-carrying neuroscientist for many years. Like there are a lot of loan words that people kind of grab, like attention. Like there's an important mechanism that makes transformers transformers. Transformers are the architecture that powers all the models that are making the news, and they call it attention. It's like, that's a word that has a meaning, like a precise technical meaning in neuroscience. But words have multiple meanings in different contexts. We deal with that all the time. I'm a little bit laissez-faire about words because I find myself in the business of like building machines that understand human words, and you're like, it's all a mess anyway. Like this is crazy, like languages vary from, even over short geographies. Like I
Yeah.
could tell somebody's from central Massachusetts where I grew up based on the words they use, and that they're not from Boston, where there's little subtle variations in the words we use. So there's
Yeah.
not one way to produce language. So I kind of like, on one hand, it drives me nuts because it's like, don't use that word. That gives you the wrong impression, I think is the bigger problem. Like hallucination makes it think like, the models are like on drugs all the time and kind of like floating around or something. But it is just, it's actually like a word I like better is bullshit. It's like they're bullshitting. Like the model is trying to produce its best guess at it doesn't know. Like the knowledge is not there, it's not surfacing out, but the way it's trained is such that it's better off. It optimizes the goal it was given better if it produces plausible sounding bullshit. So yeah, from that standpoint, I don't love it, but but I have more of like a use-based sort of crankiness about words. I don't like when we put a word on something that gives you the impression that it's something it's not. Actually, the word that drives me the most nuts these days is agent. Not because not because there isn't something that has agency and would fit that definition, but now everybody calls everything agents. Like
Yeah.
like it's a function, and now it's an agent. It's agentic this, and I'm just like, it's such an overused word. And when a word gets used for everything, it sometimes means nothing. So, um, yeah, that's my get off my lawn sort of moment for for today. It
Fair
sounds like
enough.
you're in the same boat.
Yeah, yeah. So yeah, Enrique, and that was just one of the questions I was going to ask is so AGI. So you're working in the artificial intelligence world, and so all we're hearing right now is AGI, and apparently this is
Mhm.
more dangerous than nuclear weapons and blah blah blah. Um, do you think AGI is real that we can get there? And then from my perspective, do we even want it? Like one of my questions, like there's this huge thing for AGI. And I don't want my car to write poetry. Like,
Right, right. Or experience anguish. Like it's just
yeah.
surplus to requirement. We do not need, like my HR chatbot does not need to like ponder life or like or be super intelligent at physics. Like it's a bit of a weird thing, and I think so personally,
Yeah.
and this is kind of meshes with IBM's philosophy. It's consistent with the models we built. I see these as tools, like like let's build something useful, and I don't need my HR chatbot. Like I want to build lots of companies want to build assistants that make it easier for their employees to find out information they need to know. So like how many vacations days do I have? What's the policy? Whatever mundane stuff. Like you don't want to spend human
Yeah.
time on that. Does that chatbot need to know advanced physics? No. Does it need to write poetry? Definitely not.
Yeah.
Does it need to be superhuman in its capabilities? Like, not really. And when you pick it apart, even very advanced things, like say I am doing physics and I do want it to build the next fusion reactor design, it's still not obvious at all that that needs to be like a human-like intelligence. Like it's a bit of a weird goal, and certainly in the near term, like I don't think we need it or want it. Like these things come with consequences too, because if the model is huge, takes a
Yeah.
huge amount of energy to run, it's going to be very expensive. Like it'd be better for the planet, it'd be better for a business paying for it if they had something that was like tool-like, small focus, does the thing it needs to do, doesn't do more than that, helps people do things rather than, I think there's also a slightly problematic undertone sometimes about like, well, if we had like, digital people, we'll just replace the real people or something. And that's not what we're trying to do. Like tools we know how to use. We've been using tools forever. That's what all of computers are, is a tool. And yeah, it changes labor markets. Like it used to be in 1900, most of the population was involved in agriculture. There were farmers. Now we don't do that. But we do other things, and like like it's a process of augmenting ourselves. So I don't have any like deep problem with people wanting to chase AGI. It's just not the thing I think we need right now, and I think it's got a lot of potential issues. And I'm especially worried when there gets to be kind of like religious, almost feeling kind of overtones to it. Like we're gonna like summon the AI into the world. And I don't know if you've heard of Rocco's basilisk.
No,
There's
no.
this weird thing, idea that we have to help AI become real. It's a super intelligent AI. And if we don't, the AI will punish us for not having helped it. And if you've already died, and this is hundreds of years in the future, it will digitally reincarnate you and then torture you, your digital copy, because you didn't help. It's like, this is some really weird stuff. And like, I had never predicted when I was, like writing little computer programs in my basement with the computer my dad brought home, that someday there would be people talking about like digitally reincarnating people. It's just it's got a lot of fringe element to it. The danger thing you mentioned, where it's like, oh, this is so smart that it's now dangerous. It's going to build a weapon or something. On one hand, again, like if you take a tool framing, it becomes much less. That becomes much less scary. It's like I'm just building it to do this thing. I know what I'm building it to do. It's going to do that. And if it's doing other things, that's maybe even something we should not have it do. But also, I think you have to examine the motive sometimes of who's saying that and who's saying that in Washington, D.C., for instance, because some of these players want to get sort of regulatory capture. They would like to regulate it such that only they can do it, and that there can't be open ecosystems and things like that. So that that sort of question, the debate about what are people's motives and things like that, that's been going on for a long time. And people are always there's always gonna be a lunatic fringe on any of these things. And then beyond that, it's just a difference of opinion. Do you need general intelligence, or can you get by with somewhat more limited intelligence? And it's a debate. We'll find out what the right answer is as time goes on.
I mean, do you think we can get to general intelligence? Because one of the things I think about, again, coming from a background of criminal justice and dealing with that world, is one of the things I always tell people is like you can't abuse a computer. Like we are the products of our lived experience,
Mm.
both good and bad. And that's the interesting thing. Like sitting there and trying to study, like literally you have identical twins. One becomes a
Mm.
criminal, one becomes like a CEO.
Yeah.
Why does
Yeah.
that? And
Mm.
so like computers don't have lived experience. So even when we're talking about artificial general intelligence, do you think the people that are selling it actually know what they're even trying to sell? Like, what is this thing they're trying to offer us?
Yeah. I mean, they have training data, but I think there's a couple risks with the AGI sort of framing. And I think you said very aptly one of them, which is, does anyone even know how to define this thing that we're building, like we're supposedly doing, that's going to be great and terrible, and have like have weird sort of rhetoric around it? We don't really know what it is. We can't define it. And if you're coming from like a computer science or a science background of any sort, that makes people uncomfortable. It's like, I don't even know what it is. Like, I can't build it if I don't even know what I'm supposed to be building. Um, and I do think there are interesting dimensions. Like you might remember, it seems like ages ago now, there was a freak out because some Google employee like suddenly became concerned that one of their models was self-aware or something. It's just such a weird place to be. And we're just so good. It's just we're so good at fooling ourselves about these things.
Hmm.
Like
Okay.
like we anthropomorphize like at the drop of a hat, right? Like people had pet rocks. Like, my God, pet rocks. Like with that, that's the most inanimate object possible. Like, I talk to my dog as if she understands what I'm saying, and I'm quite sure I ascribe all kinds of mental and processes and understanding to her that she just doesn't have. So, I think we're gonna be constantly fooling ourselves into thinking something is not what it is. We're gonna be, not defining things and running with them. It's complicated.
Oh, fair enough. So then when we're talking about models, one of the big things, again, AGI and probably second on the list is safety. Nobody will shut up about safety.
Mhm.
So you being VP of AI models, how do you perceive safe? Because it's like I get the concept of you don't want to teach kids how to use napalm. But then you get into this weird thing of, especially with the isms in the modern world, if you say something improper about something that is unsafe, like that gets really weird too. Like with IBM and with you, like when you're thinking about model safety, what does that actually mean to you guys?
That's a great question. And, I don't think it's like well defined what it means for a model to be safe or not safe.
Yeah.
An application, a usage of a model can be safe or unsafe. And then you have to say, like, what is it safe or unsafe to? Like, we have to be a little bit more specific. Like, is it actually dangerous? Like, if you um, I saw somebody did an experiment, like just kind of for fun, where they had LLMs trying to do air traffic control in a simulator. It's like, is that a safe application? Absolutely not. And they knew that they were doing it for fun, but it's the application and the use of people's private data, the interaction with people. That's what makes something safe or unsafe intrinsically, and that's what if there's going to be regulation around AI, it should be targeting the risks, not like the actual application, the use, the actual harm that you're worried about, rather than trying to regulate the model or something. And, like what might be reputationally unsafe, like, if your model says something, like if you have a chatbot, which is
Yeah.
model plus software, and it says something embarrassing that could damage the reputation of your company. That's a kind of danger, it's a kind of harm, and you'd want to be safe against that. So I think for us, it's more about, can you build the structures you need to put in like a framework of software and monitoring and people and stakeholders that can, like, if an issue arises, you know why it arose, you can react to it quickly, that you have some sort of governance around, is this a good idea to do this with AI or not? AI therapist is one that keeps popping up again and again and again. And that one, like all the ways you might predict, it keeps causing problems because like you're dealing with a vulnerable individual
Yeah.
with a system, and you have to be really careful in those settings. So, I don't think it's safety of AI per se. It's about, like, can we be smart about what applications we tackle with AI? Can we be smart about the guardrails we put in when we deploy those applications? And, sometimes the answer is no, you shouldn't do that with AI. That's okay. Like, not everything should be, or at least not yet. And, so it's complicated, but it's complicated on one hand, and it's kind of obvious on the other hand. Like, it's just be thoughtful about what you're trying to do. And it's a new technology, and I understand why people are getting tripped up. But, you know,
Yeah.
that's kind of how we feel about it.
So then when you guys are looking at it, are you looking at model safety or are you looking at like the AI platform safety for filters and what's in your RAG and that kind of thing?
Yeah.
Like, is it the platform that needs to be safe, so not the model per se?
Well, it's both. It's both. So, we do safety training of sorts on the model. Like, we don't want the model just, going off the rails randomly. We want it to, one of the advantages we have is we're not doing direct consumer product. Like, our customers are businesses, so we're giving them products that are for business use. So a lot of times, a lot of the controversial topics that might, like, we'd rather have the model just not talk about, politics, or it's just like the default behavior is kind of, business, like you just don't have a legitimate purpose to even engage in certain things. But more importantly, we build the tools that let the customer craft that environment around it, like being able to track what it's doing. We have a model called Granite Guardian, which is a variant of Granite, which is for guardrailing. So like if you can check the responses and if it'll flag if there's something you might be concerned about, or check the inputs the users are coming with and decide whether they're trying to subvert the system, if they're trying to like hack something. And those models are some of the best guardrails that exist. You don't have to use them with other Granite models. You can use them with any model you like. But they take, I think, last I checked, it was like 7 of the top 10 spots on Guardbench, which is the EU's safety, like guardrail benchmark.
Yeah.
Um, so yeah, it's about tools. Again, like everything for us kind of basically comes back to like we're going to empower you with good tools that are straightforward to use that help you do the things that you would need to do to deploy this technology in a responsible and trusted way.
Fair enough. And do you think it's fair? So, like in the media, like you go to TechCrunch or whatever, and they'll spend like 3 hours getting an AI to say something stupid. Do you think that's actually is that actually penetration testing, or is that I can open up pages and write something horrible? That doesn't mean I hacked pages.
Yeah, there's always going to be a sensationalist element there. Yeah, we've responded to a few that were pretty wild. Like really, guys, like that's not how this model is meant to be used. But anyway, it's good on one hand. People should be going in there and kicking the tires and finding out because it's very like discovering new paradigms for how you can trick a model into doing something that it shouldn't be doing is definitely useful. And like we're working with HackerOne to like launch like a white hat hacking to like try and subvert different aspects of our system because that helps you build stronger things. There's always going to be some sensationalism, where people like work really hard. The one that happened a lot early on was they basically asked the model to role play, and the model role played, and then they just took the part where it was role playing, and then they didn't show the part where they asked it to role play, and they say, "Look at this crazy model." It's like, okay, well, yeah, I don't like it's just part of the game, I guess. But I do think it's important that people try to find vulnerabilities and tell the companies about them, tell the field about them.
Oh, fair enough. And then, so Anastasia has a question. So, with education, so with AI is such kind of a new thing, or this version of AI is such a new thing. Like, how do you guys deal with employee development, like at IBM? So the current employees that you already have,
Mhm.
how do you keep them up to speed?
Yeah, we do a lot. I mean, we have many internal educational programs available. We produce content both for internal and external consumption where people can learn more about these technologies as they emerge. Um, Obviously, the best way to learn something is to use it and work on it and get mentorship from people who know how to use it. So I think the entire software industry right now is increasingly transforming so that people are finding more and more of AI in their everyday work. So, a lot of it's learned on the job, some of it's educational materials. We run something called the Watson X Challenge every year, where basically the whole company is invited to go and like pitch an idea, build a thing based on AI products and learn in the process. It's really a learning exercise. And I think those can be especially when you have a kind of like a community spirit around it, everybody's doing it. I
Yeah.
think that could be a very effective way to learn as well.
Hmm, okay. And then I have one other question from Christoph, and this is kind of interesting. It's kind of long here, but breaking it down. So, especially since you're neuroscience, since IBM is a global company and
Mhm.
people around the world in different countries look at technology different ways. Like they talk about that, like Japan. When Japan thinks about robots, they come up with fake seals. When we come up with robots, we come up with Terminators. And so, like, when you start talking about things like artificial intelligence, is there anything interesting you're seeing in just how different cultures kind of perceive this? Like, do the Japanese perceive AI in a way we
Mhm.
don't, or the French or the Chinese or whatever? Yeah.
Yeah. Yeah, it's interesting. The robot seal one is interesting because it is interesting how many of like the funny like oh that's a weird Japanese technology thing. How many of them are really like assistive devices like they're like helping an elderly person, helping somebody be comforted, things like that. So uh, that's an interesting cultural misunderstanding, I think, on both sides, which is kind of interesting. I think every culture is so different. I mean, we are a global company. We do work about basically in every country there is. And I've actually, especially before the pandemic, but even after, like our team is global. I think we're in 6 or 7 countries, um, and just my team alone. And we work with the local teams in many of these places. There are differences, like and some of them are subtle, and some of them have to do with more like how you would say you're sorry is a little bit different
Yeah.
everywhere. Like when is it appropriate? When is it necessary? What's the right way to do it? How do you? And if we're going to have conversational interfaces, we can't have a one size fits all for AI. We're going to have to get to the point where we have customization, tailoring. Different companies have different cultures and values, like let alone different countries. So I do think that the one only model, like this is why some of the safety things are maybe even especially challenging because what would be considered safe or embarrassing, in different contexts might vary. So, I think culture is a big part of it. There's a big trend towards nations creating their own models. They call them sovereign models. And it's
Yeah.
partly in response to that sort of idea that like, hey, our language, our dialect, our culture is our own. And like, we're not going to let some other American company or Chinese company tell us how to do this. We have to do it ourselves. And then there's just tons of mistrust at the nation level too.
Yeah.
Um, you know, different countries are you comfortable with a model coming from here or there that, is controlled or not, like by different players that there's a lot of sensitivity there, especially in this moment. So yeah, it's important. It's important, and we actually have to we deal with it, because we operate in so many countries.
It's interesting. So with the models, I mean, is the concept of like localized models somewhere in the future? We're just not there yet. Like I think about like localized operating systems and God knows what they're actually saying. You're just like, eh.
Mhm.
Like, are you guys looking at because you talk about the cost of training a model. So
Mhm.
I can't imagine training more or less the same model 100 different ways is cost
Yeah.
effective. Like, how would you go about localizing models?
Yeah, I mean, so almost all the models that are available today, including ours, are quite multilingual. They can speak. We officially support 12 languages that sort of map to the 12 biggest markets, and the model probably speaks others that those are the ones we evaluate and test. Um, Now there is interest there. There are some languages that aren't amazingly well served by any model, even like doesn't matter where it came from. Like it's like big model, small model. It's like they're just not well served. And some of that has to do with the fact that there's so much more English data on the internet than there is other languages. And once you get onto the long tail, it gets pretty slim. The local, I think it's more plausible for a nation to have a national effort, partnership between public and private entities to create like a localized version than it would be for them to create it from scratch
Yeah.
in a language. And we're starting to see that pattern emerge a lot. And we've actually had some engagements with different countries where we're basically like assisting them in taking, you don't have to do the whole thing at the full cost, but maybe you want to customize it on top, or you want to ensure that already existing language skills are better in certain languages. And a number of nations are sort of working on that and spending, real effort on it. But we'll see where those go. I think the idea that a nation, I think there's a lot of interest in owning it, right? And not having it be owned by a foreign company, and having it represent the values of that country. So I think, we have a lot of technologies that we're developing even now to allow companies and different players to customize how the model behaves. And I
Yeah.
do think that's going to be super important, even beyond language.
Oh, interesting. So one of the things I think about, yeah, we're
Mhm.
an hour and a half into this already. So I have students, and one of the interesting things is so you start learning and you start learning based off of the world as it is now, and you graduate versus in the world 4 or 5 years from now. So I talk about like LLMs being very 2025. And being in
Mm.
this field, I feel like probably the hype curve is kind of getting to the high point.
Mm,
So if I have like 18-year-olds that are thinking about going into computer
mm,
science programs now, what what do you think is going to be the valuable thing in 2028 or 2029? Like if this is where we're at now and this is not where we're going to stay, where do you
yeah.
kind of see the value proposition going?
Yeah, no, that's really hard. Like predicting, people ask me that a lot if I like speak publicly. The big people are like, what should my kids do?
Yeah.
And usually my stock answer is a joke. I just say like you should be a like autonomous vehicle personal injury lawyer because there will always be lawyers to, like if a like if you could be an AI lawyer or whatever. It's really hard to predict. I think there are a lot of people predicting the end of software. But
Yeah.
people have actually been predicting the end of software since COBOL because COBOL was actually believed to be like, oh, it's so close to like a business person could express business rules directly in COBOL. And if you've ever looked at COBOL, that's absurd. Like people have been like sort of declaring the death of software and programming for a very long time. And now people are vibe coding it, and you can do some impressive things. It can be an impressive tool to augment your abilities, like how fast you can code and all that. But there's no substitute for like, at least not now, for
Mhm.
that sort of reasoning about what you want to do and thinking about the high level structure. Now, it may be the case that that even yields at some point.
Yeah.
It's really hard to predict what the future holds. But I think it's just important to like to really lean in on the thinking, like the actual anything that feels mechanical, like it's just like you're just going through the motions. That's the kind of stuff that's going to be, automated away. But I think again, best of times, worst of times. It's really things are moving very fast, but on the other hand, there's lots of challenges and very hard to see when those are going to intersect and cross over.
Okay, fair enough. Do you think it's still worth learning computer programming? Because what I find bizarre is like the parents, worry about computer programming, but I've talked with like startup founders and people that have been in the tech world for 15
Mm.
years, and it's amazing how many of them are actually flagging their kids off of computer science at this point.
Mm.
Um, Now, with LLMs and such, I mean, I completely agree that they're a force multiplier, right? If I need to write in a language I don't know a lot about, it improves syntax and all that. Do you
Yeah.
do you in like your world, do you see computer science going away?
I, you know, I don't see it going away anytime soon.
Okay.
Again, we've been getting better tools. It's been getting easier to program. That's actually just opened up the aperture to have more people building software, right? It's not like there's a finite amount of software we need in the world, right? Like that can be an arbitrary amount of software. And, what role we'll play in it. I mean, it's not the case that people all learn machine code or assembly anymore.
Yeah.
Like some of these things are actually falling out of computer science curricula. And, that would have been equivalent to saying, like, are people going to learn to punch cards,
Yeah.
in the future? Is that a good career? It's like, well, it's going to move and adapt, and you're going to move up the stack, target higher value things. So I think for the foreseeable future, there's going to be you're just going to keep moving up. It's going to make it easier to produce more software, better software, and we'll just keep riding that for a while. But labor markets ebb and flow. This like, people come out of school, it's a bad year, nobody gets jobs, it's very painful. Then it's booming, you can't get enough programmers, everyone wants so we're going to see those kinds of flows. Some of them are going to be driven by AI. Maybe there'll be long-term changes, like how in agriculture we went in 100 years from everybody doing it to nobody doing it to a first approximation. That could happen, but it'll happen gradually. And I think the only piece of advice that I would give to students is just stay nimble, learn, change, follow what's happening. Like don't get stuck in a narrow niche. Just keep learning because you want to follow the opportunities. Their programming languages come out so frequently and paradigms shift. You
Yeah.
can't just learn one and stick with it the rest of your career, except for COBOL. COBOL, you can do that.
Yeah, you got
But
that.
you just have to stay nimble and stay learning. I think that's really the key I would give. That's the advice I give to my own kids. Really.
So with the people that you're around, like one of the things that I find bizarre is this whole AI thing has made so many technology professionals at all levels. like horribly depressed. So I've been doing this. So I started in tech in 96. So I've seen arrogant and sad. I've seen lots and lots of different behaviors out of geeks. I have never seen this level of just out and out depression. Like this
Wow.
idea like game is over. Do you get that in your world, or are you guys all just happy and I don't know.
I don't know. I mean, we can be unhappy for other reasons, but
Yeah.
yeah, I mean, I don't think there's anything to be depressed about. And I actually think there's just so much opportunity and there's some really important work that we need to be doing right now to really even get the value of this, right? It's a little bit hard be super worried about something when it's like you also see like the parts not always fitting together or it being harder than it needs to be. So I don't know. I mean, we have emotions swing big these days. It's hard to say, but I think everybody here is pretty optimistic. I think this can do a lot for us. It can take away things that are annoying and drudgery to do, make us more effective in the long run. That's the vision we're all aiming for.
No. So you guys see this more as just another like tech stack versus indie game, I suppose.
Yeah, I think people have declared endgame about lots of things, and it hasn't been right so far. And really, it's going to be if we ever do get to that point where the whole thing goes away, or like there's nothing that we can do that AI can't do better, then we're going to have like actual like important structural government social changes to accommodate that. But in reality, I think right now we're moving through an exciting tech stack
Yeah.
phase, but maybe not one that's completely different kind. And I will have to head out shortly, but I think we're a little bit over. But yeah, it was a lot of fun.
Okay, good. Yeah, I was glad to have you. So anybody home? Yeah, I thought we were only gonna have an hour, so we got an hour and a half, so it was good. If you have a minute, like, is there any final? We got I don't know, 15 people on, and we'll go out to a couple thousand on YouTube. Is there like a final thought for people about IBM, the AI world? I don't know, joke.
Yeah. No, I mean, I think my big theme is that like this doesn't end. Like in some ways, it relates to your last question. I think this is part of software. I think we should treat it like the enterprise. Like it's just like we're building really cool software. We have really cool new tools, and I think if we do that and we don't anthropomorphize it, in weird ways, I think it's really exciting. I think it's going to help everybody. I think it's going to open the aperture where a lot more people can do computer science in their everyday jobs. So that's the positive message I would just like to go with. Like, this needn't be scary. This is actually exciting, and but we should treat it like tools.
Good deal. Cool. Well, thank you for being here. Everybody else, I'm about to kick you off to the waiting room. This will get uploaded to YouTube, and I don't know, either tonight or probably tomorrow. And we continue to do these. I'm going to schedule some more of these. So if you go to silicondojo.com, you become a member. You can come and participate in these fireside chats. So, David, if you stay here, I'll kick everybody else out. And see y'all later.